Okay, this is the setup. We have on the right the iHealth smart sensor and the specific blood pressure smart sensor, glucose level 1 and blood oxygen 1. Then we have our Raspberry Pi switched on with a Wi-Fi module, so it is connected to the Wi-Fi. It has set in it a static IP. It contains all our application scripts and it will work as a remote server. Then we have our smartphone in which we have installed the iHealth app, and then on the left a standard PC with an executable file.
This is basically how the system works. A personal computer connects to the Raspberry Pi and runs web service Python script, which is accessible to the PC and through which it can control program in the Raspberry. Patients send measurement data through their iHealth sensor or using manual input mode. Raspberry Pi receives them, process and give output that can be accessed through the web service. The Raspberry Pi will work as a remote server, so we just run an executable file from our laptop. This will connect to the Raspberry Pi via CQ shell. The Raspberry Pi has set a static IP. It changes directory and runs the web service Python script. From now on, we can control our program from the web service. So we reach our web service, and the first step is to add a new patient to the database. So we fill out this form, writing basic patient info like name and age, physiological information like parameters, range, and additional info. We also need to write down communication info to let the program automatically communicate with Telegram bots, TeamSpeak channels, and iOS Glad. Links for getting such data are provided. TeamSpeak data is got when a new channel is created. Telegram data when a new bot is created. iHealth one when a new user registers to the iHealth app. When the form is submitted, the program will save all this data in a JSON database. Which contains all patients' info. It also creates new lists in the JSON measurements database under the new patient's name, ready to receive new data. Now we can move to another service, which is Show Patient Data. We click on it, write down the patient name. The program will show patient data, and also the right TeamSpeak channel is open, showing parameters measurements plot. The program can be used in two ways. The first one, that can be run by clicking on Listen Measurements Incoming on web service, is used when patients own iHealth sensors or iHealth app. Patients send measurements to their doctor with their iHealth sensor or using manual input mode. The program receives them and checks the user ID that it is associated with each iHealth app, so to each patient. And this way, it's aware of patient identity for doing all the work. in a clinical context, in which just few sensors are necessary and they are used to take measurements from all patients. In this case, user ID cannot be used since it will be the same for all of them. So, patient name is required and passed as argument to the program, which does all the work under the name provided. Let's see how the professional mode for using the program works by clicking on Listen Measurements Incoming. The program will open 5 terminals in which are running our 5 microservices. The one in the middle, the MQTT publisher from IELTS, receives data that is pushed via DWIT from IELTS Cloud. Prepare a payload containing necessary information to be sent to the other microservices and publish it via MQTT. The other microservices are subscribing for the same topic, so they will receive such information. Let's see how microservices work. Just to be faster, we can send measurements by using manual input on IELTS website. We can, for example, send a blood glucose measurement. We write the measured value and we click on Submit. This account is associated with a user ID, so the program will do all the work under it. We submit the message and check if the microservices receive it. That's it. The save-on-txt microservice saves the measurement in a patient's measurements database, which is in JSON format, under the right patient name and kind of measure. Let's check if it works by opening the JSON database. This is. And under glucose level, this is the measure. The classify plus alert one checks if measure value is out of its physiological range and eventually send an alert message to the Telegram bot associated to that patient. Let's check if Telegram bot receives such message and that's it. There is a warning, the parameter value, the range, and the date. The Save on ThinkSpeak microservice updates the right ThinkSpeak channel via MQTT communication. We can check by using the web service, clicking on the option Show Patient Data, write the patient name, and check it. This is. The last microservice, called Send Plus to Telegram, listens to all patient Telegram bots and, if a request is received from a bot, it creates a measurement plot and send it back to it. Reaching the Telegram account, we can send a request to a program in the following format. Kind of measure, number of measurements, the plot is sent to Telegram bot, and that's it. We can now have a look at the clinical mode for using the program by clicking on Technique Measures, writing down the patient name, submit it, and the program will open also this time 5 terminals with our 5 microservices running them, and the program is aware of the patient name, so we can send a measurement using whatever account we want, because the program doesn't care about user ID but just about the name we wrote down. So let's do it. Okay, the message arrived. Let's check if it was saved in the right position. Yusuf Balasa, this is, and now we can check for the TeamSpeak channel updating by reaching the web service and show patient data, digit the patient name, and let's check it. This is